Good evening. First tonight, making driverless cars a reality and the latest work being done in Oxfordshire to get autonomous vehicles on the roads. It involves mapping 20 miles of streets between Oxford and Abingdon in minute detail. Before the cars can operate safely, firms will need to know every feature of every road to an accuracy of around a centimetre. Once the streets have been mapped, the plan is to create a simulator to put the technology to the test. Here's our transport correspondent, Paul Clifton.
Collecting data, vast quantities of it, to a new level of accuracy. This is a trial. The car is following a route around Oxford and Abingdon.
So the lasers on the system capture 2 million points a second.
2 million every second?
2 million points a second, yeah. Each one of those lasers will be measured to around 5mm accuracy. So the system is capturing everything that it can see at a very high level of accuracy. So we're seeing the road markings, the curb lines, the street furniture.
The result will be a three-dimensional digital map like this, combining billions of pieces of data for every journey. Even the tiniest roadside feature has to be recorded. The height of a curb, the position of every driveway and every road sign. Before a truly driverless car can operate safely, it will need to know and respond to all this information.
The problem we're trying to answer is, how do you know if self-driving cars are safe? So what we're building is a simulation that looks just like the real world, where you can test a self-driving car and prove it's safe before you allow it out on the real road.
The data from Oxford will be crunched here at the Ordnance Survey in Southampton.
This particular model, the accuracy is around about 6 centimetres.
Is that accurate enough for driverless vehicles?
No. We need to capture a much higher level of accuracy, probably around about 1 centimetre to 3 centimetres, to model accurately the curb when it drops down so that a vehicle can go up onto a driveway.
It will also be used in this simulator. For now, it has a driver, but in due course, it must drive by itself. So you're dealing here with people doing unexpected things. Give me an idea of the volume of data you need for that.
For a human driver, there are a number of sensors that we use, our eyes and our ears, in order to drive and to understand what's happening around us. For the driverless car, it uses a number of different sensors, such as LiDAR and camera and radar. And we're using the data from millions of insurance claims where there have been collisions in order to build up that knowledge about how humans drive and the kind of accidents that humans have, so that we can really test the autonomous vehicles.
End of scenario.
I think it's not next year or the years after technology, for example, but it's on the horizon. On the other hand, it's not kind of in Never Never Land of eventual time. It's somewhere in between those things.
And that gives you an idea of how far away we are from truly driverless everyday motoring. Paul Clifton, BBC South Today, Oxfordshire.